Hey guys, welcome back to Mr. Bennett's conceptual chemistry videos. We have finished Unit 1, we're moving on to Unit 2 now, talking about classifications of matter. And our first section, Notes 2-1, is going to talk about the properties of matter. So the first thing we need to do is we need to define what matter is. Matter is anything that has mass and volume. These are two units, or actually quantities, that we've talked about in the past, but realize that you need both of them together in order to have matter. So if we go back and just review for a moment, volume is the amount of space that an object takes up. So if I have a cylinder, this cylinder occupies a certain amount of space. Okay, not the prettiest cylinder in the world. Tighten that up. Anyhow, so that's my volume. It occupies a three-dimensional space. Mass, on the other hand, is the amount of matter that makes up an object. So this particular cylinder over here is made up of tiny little particles, atoms. They take up space. Okay, each little atom or particle is an amount of matter that is making up this object. So you need some matter, and that matter needs to occupy space. Remember, mass is not the same thing as weight. Weight factors in gravity, and when we deal with these scientific measurements, we don't want to think about gravity. We don't have to deal with that extra factor, so we deal in matters of mass. In this unit, I'm going to talk a lot about substances, so we need to explain what this word means. A substance is a material with a definite chemical composition. What does that really mean? A bunch of scientific words. It basically means that when I use the word substance, it's just a generic term for matter, meaning that I want to talk about an example of matter, but I don't want to identify it as being iron or copper or oxygen or water or some other type of matter specifically. I'm just using it as a generic term. Now, the main idea of this video is the idea that matter can exist in three states on Earth. There technically is a fourth state, you can get into plasma and things like that, but we're going to focus on three states of matter. So what a state of matter is it's a physical state, and it describes the form that matter takes as a result of the arrangement of its particles or pieces. So if we go back to that idea that an object, to a cube this time, if an object is made up of tiny little particles, so if my cube, for instance, is made up of tiny little atoms, right, or molecules in here, if this was an ice cube and these are little water molecules, right, the form that this piece of matter, that this bit of water takes, is based on the arrangement of its particles. So the arrangement determines the state. So how these little guys are arranged, how they're interacting, will determine which state of matter you're in, whether it's going to be solid, liquid, or gas. Right? That's all determined by how these little pieces, the atoms and molecules, are arranged. So the first state of matter I want to talk about is a solid. Solids are particles that are packed very close together. So they're nice and tight. Here we have water molecules that are nice and tight together. They can't really move. In fact, the only type of movement that they can make is they can vibrate. So they can kind of vibrate in place, jostle a little bit. But other than that, they can't slip and slide, they can't move around each other, they can't ping pong around. They're pretty much just fixed in place. And that goes on to explain that solids, in terms of their shape and their volume, they are fixed. That means that they don't change. So if you think of solids, what we think of solids is that they have a shape or a substance that does not change. The desk at school, for instance, you can't move it around, you can't flow it onto the floor, it doesn't bounce off the walls. Okay, it's a solid piece of material that has a fixed shape. The volume of that table is also fixed, meaning you can't compress it, you can't make it occupy less space, and it can't expand to take up more space in the room. It's fixed. It does not change. With liquids, the particles are still close together, but they have the ability to slide past each other. We use the word flow to describe that. Water flows, right? It flows downhill, it trickles, right? We have all these different words to explain the flow of water, but what's really happening at the molecular level with water is when it's a liquid, the molecules have the ability to slide past each other. So here we have the molecules slipping and sliding, moving around. They still have to stay relatively close to each other, but they can kind of slide past each other. And what that's going to do is it's going to allow the shape to change, because as they slip and slide, they can readjust to fit the container that they've been put in. So if you go down the water aisle at the grocery store, for instance, when we sell water bottles or when we buy water bottles at the grocery store, they come in lots of different shapes and sizes, but if you look at the amount of water in those bottles, it typically is about the same. So I could buy a 16-ounce bottle of water that maybe is a nice clean cylinder, or maybe I can buy a 16-ounce bottle of water that has more of a, I don't know, just weird rounded shape. Or you could go with that whole like the Fiji bottle where it's kind of like almost like a cube, right, with like some weird kind of top on it or whatever. But anyways, so horrible Fiji bottle. But point being that the shape can change. I can take the same amount of water and I can put it in different shaped containers. However, the volume is still fixed. I cannot make the water occupy less space. Water also cannot expand in a liquid form. So the volume is still fixed. It cannot change. All right. So what that means is that solids and liquids cannot be compressed. Basically, I said neither solids nor liquids can be compressed. Okay, they cannot be compressed. So we cannot reduce their volume. All right. Now the third state of matter, gas, is going to free all this up, meaning that in a gas, the particles are free to move as far apart as they want. So over here, if we think of this white field here as being a container, these particles can bounce around as much as they want. They can bounce off the walls, they can bounce off each other. They're free to ping pong around as much as they want. They don't have to slip inside. They can ping pong. They can go as far apart as they want within the confines of this container. Okay, what that's going to do is it's going to allow both the shape and the volume to change. So they're both free to change. And that means that gases can be compressed. They can be forced to occupy a small container like this, or if we open up this container, they'll spread out or expand. So if we think about it, we had three phases, right? We had solids, we had liquids, and we had gases. And we just described them in terms of shape, and we described them in terms of volume. We also described them in terms of their ability to be compressed. So a solid cannot change its shape, nor can it change its volume, nor can it be compressed. So it's sad all across the board. It has a fixed shape, it has a fixed volume, it can't be compressed. Liquids, on the other hand, can change their shape, so that's cool, they get a happy face. They, however, are stuck with their normal volume, so they're sad. And they also cannot be compressed. Gases, they're happy across the board. They can change their shape, they can change their volume, and they can be compressed. Okay, so think of it in terms of freedom. Gases have the most freedom, solids have the least. They're stuck the way they are. Gases have the most, they can move around, change their shape, change their volume. Liquids are somewhere in the middle. Shape can change, volume is still stuck. The last idea in terms of states of matter that I want to explain is this idea of vapor. Vapor is a gaseous state of a substance that is coming off of a substance that would normally be liquid or solid at room temp. So two examples of that would be something like gasoline and something solid like Vicks Vapor Rub. Gasoline is a liquid. When you look at it at room temp, it's a liquid. However, you can see the little vapors coming off of it. So if you have a little pool, you can kind of see the gas vapors coming off, and you can smell it. Anything that you can smell, like perfume, things like that, they're liquids. But then if you open the container, you can smell it because some of it is evaporating as a gas, and you can smell that at room temp. Same with Vicks Vapor Rub. It's a solid. You rub it on your body, but then the vapor, the gaseous Vicks Vapor Rub, goes up into your nose and helps to clear your nose when you have a cold or you're congested. So everything we've talked about today is a physical property of matter. That means that these are qualities or conditions of a substance that can be observed or measured without changing its composition. So I can observe the fact that an ice cube is solid. I can observe that it's a liquid or a gas without changing the fact that it still is water. Okay. I can, for instance, look at the property, the boiling point of water. I can determine that it boils at 100 degrees Celsius and it's still water. I can measure it, I can determine the boiling point of water, and it still is water when I'm done. Now, to do that, I have to observe a physical change. So if we go back for a second, a physical property is observing a change, okay, a change that does not actually change the composition, doesn't change the type of matter we're looking at. So I can change, it's a change to a substance that does not change its composition. Be something like melting an ice cube into liquid water. Goes from a solid to a liquid, but it still is water, right? So that finishes our notes for notes 2-1. Go ahead and complete your whisk. Make sure you submit it online. Make sure that you fill out all those little boxes and hit submit. If you don't, it won't get submitted if you don't submit, like if you leave a box empty, because they're all required. And I will see you guys tomorrow.